It was on the extra practice. I'm going to skip to 10 and 12 because I can kind of see that those are two different strategies that we worked on. What strategy should I use for number 10? Anyone remember what that's called? It could be greatest common factor. Do these have a greatest common factor? No, but I should check for that first. That's a good strategy. What was the second strategy we learned? This number 144 should ring a bell. Like, that's a perfect square. So the pattern is that you take the square root of each of those things. So x times x is what gives you x squared, and 12 times 12 is what gives you 144. Anyone know the special name for 12 items? A dozen, right? What's the special name for 144 items? It's a dozen. It's called a gross. Have you ever heard of that? So like a store, if they were going to buy like, you know, so many dozen boxes of eggs or whatever, that's a gross. It's an amount. I don't know why they gave it that name, but one gets a plus, one gets a minus, and then it's equal to 0 over here. So I actually have to solve for the two x-intercepts. So what are my two x-intercepts for this problem? What will make this 0 and what will make this 0? So this one would be negative 12, right? And this one would be positive 12. So my two solutions are negative 12 or positive 12. All right, I picked number 12 to do next because I see 4 terms. So when you see 4 terms, you should either think I can either do grouping or I could throw those into a box and do the box. So either, you know, group them together and try grouping, or set up a box for yourself and do the box for a minute. So this would be 3x squared, 5x, 21x, 35. So see if you can solve for the two facts what x is. So people got 3x, x, 5, and 7, right? So x plus 7 times 3x plus 5. So those are your binomials. But when it says equals 0 over here, they actually want you to find a solution. So here, that one's easy. X is just negative 7. If you can't do this in your head, you set that binomial equal to 0. And then you'd subtract the 5 to the other side, and then you would divide by 3. So it would come out to negative 5/3 as your second solution. So that is a little bit harder, and I feel like that's where a lot of Algebra 2 students got stuck, is they couldn't get to this fraction answer, but hopefully you're kind of past that. I want you to look at these 4 examples that I circled. I don't want to spend a lot of time on them. They're all prime. So, oh no, actually number 5 is not prime. 6, 8, and 9 are prime, which means that I can't factor them. And if I tried number 6, how could I figure out that it's prime? I'd try to set up my diamond, right? And I would do 7 times 1 is 7. Are there any factors of 7 that add up to negative 1? It's only 7 times 1, right? Is 7, it's a prime number. So there's no solution here. So this is a prime. It can't be factored. That's why I threw the quadratic formula up here. I'm not going to test you on the quadratic formula, but just so you know, I can't tell what the x-intercepts are if it's prime and I can't factor it. I would have to use the quadratic formula. So I'd have to type into my calculator the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So did you maybe at least get exposed to the quadratic formula in Algebra 2, and then you'd have to find your decimal solution or no solution? Do you see how number 8 is also prime? Because there's going to be no factors of 1 that add up to 8, right? 1 times 1 is 1. That does not add up to 8. So this one is also prime. I'm going to skip quadratic formula. It's not as important for pre-calculus, but kind of a good to know. Why is number 9 prime? X squared plus 9. Why is that prime? Yes, so if you tried to factor that, how might you try to factor it? Maybe x plus 3 times x plus 3. When you multiply this out, you get x squared plus 6x plus 9, right? So there's no way to factor this when it's not a minus sign. It has to be a minus sign to factor it, right? Because this is incorrect. All right, so there's a couple on here that are a little bit harder. So I might not give them to you on the quiz, but you might see them on the SAT, or I might put it as a bonus question. So I didn't want to overlook it because at first glance, doesn't this look prime? Because 5 times 1 would be 5, and there's no way to get to negative 10. So you're thinking that this is a trinomial, but what is it equal to on the right side of the equation? Is it equal to 0? No. Do you see how all these other ones are equal to 0 over here? Before you can make a decision, you have to get it equal to 0 on this side. How would I make it equal to 0? What would be my first step? Yeah. So when I minus 1, that changes the left side of the equation. Now I have 5x squared minus 10x just equals 0. Now it's factorable. Which strategy should I use to factor it? Nope. Quadratic formula is a strategy when it's not factorable. We want to use one of our factoring strategies from the front page. What do you always look for first? The GCF, right? What's the GCF? So what is it for this problem? What can I divide both of those by? I can divide them both by 5, and what else? No, what variable can they both get divided by? X, right? Can I divide both of them by 5x? And then I'm going to show that I'm going to divide by 5x. So both of those terms get divided by 5x. What's left? So 5 divided by 5 is gone. What's x squared divided by x? Just x, right? And then you're right, this is 2. So x minus 2. What are my two solutions for my x-intercepts? What would x have to be here? And what would x have to be here? Yep, 5 times 0, so x would have to be 0, and positive 2. So your two solutions are 0 or 2. So to me, that's a hard problem. Starting at this step, to me, I would start you at this step on the quiz on Friday, and you'd have to do the greatest common factor. This ups the level a lot because you have to get it equal to 0 before you can start. And a lot of people would overlook this and say, that's prime, and not even try it. All right, number 7 is a tricky one. It is, there's no greatest common factor. It's a trinomial, and this 6 is a pretty big number that's not prime, and 25 is a big number that's not prime. So I would use the box method on this one, but it might be hard for you to come up with your terms. So I wanted to help you come up with your box, and then you can finish it. So this would be 6x squared. This would be negative 25. When you do your diamond, what number do you get in the top? So what is 6 times negative 25? If you have 26 quarters, how much money do you have? 6 quarters is $1.50, right? So you'd have negative 150 on top, negative 5 on the bottom. Can someone help me find those factors? What are the factors of negative 150 that add up to negative 5? Can you think of any? Yeah, so it's 10 and 5. No, wait. No, it's 10 and 15, isn't it? Because you got to get to 150. So we want the 15 to be negative, right? So 10 and negative 15 go in this box. 10x and negative 15x. So see if you can take that box the rest of the way by factoring it and then figuring out the x-intercepts for number 7. And then if you want to take a look at 13 before I talk about it, look down to 13 and see if you can figure out what you would do on that problem. Because that also is kind of a bonus type question. your two parentheses to find the x values. Let's see, this is a 3x, 2x, and a 5, and a negative 5. Is that right? You get 3x plus 5, and then 2x minus 5 as your binomials. And then you've got to figure out what x is. What are the two fractions that x would come out to? I'll write mine in a second, but see if you can solve them on your own. Let's see, our two fractions would be what? Negative 5/3, because I would subtract the 5, divide by 3, or positive 5/2, because I would add the 5, divide by 2. Are we doing better on finding those fraction answers? Because to get full credit, this is a tough problem, right? You would have had to figure out that difficult diamond with big numbers, put it into the box correctly and factor it, and solve for those fraction answers. So to me, there's a lot going on in this problem. And if it was on a quiz, let's say you start out right away and you get this diamond wrong, but then at least you kind of figure out how you would have factored it, and you at least get parentheses, you'd still have a 3 or a 4 because you're showing the steps. You just made a mistake for the first step. All right, some of you, I think, could get this one. If this last one was on the SAT and you've got a quadratic here, the only way you can start solving this is by multiplying what you've got on both sides. So this is a good review of like FOIL or multiplying binomials. So let's do it together. X times x is x squared. And then I would have a negative 1x, right? Because x times negative 1. I would have 7x, because 7 times x in the middle. And then 7 times negative 1 is your last. So first, outer, inner, last. Is that how you learned how to do it, hopefully? Or did you use the box to multiply? Be really careful on this one. You can't just distribute the 2 and call this x squared and call this 1, because this is actually x plus 1 times x plus 1. So you do get x squared, you do get 1 times 1 is 1, but you also get this additional 2 x's. You get 1x from here, and you get 1x from here. So you actually get x squared plus 2x plus 1 as your other side of the equation. So let's start simplifying and combining like terms. What would you start by doing? There's a couple steps you could do first. If it were me, I would subtract this x squared to the other side, because what's going to happen? Both of my x squareds have just gone away. So what do I have left? How many x's do I have on the left-hand side? I have a negative 1 and a positive 7. So I have 6x minus 7 equals 2x plus 1. Now you're just solving that linear equation. So see if you can get all your x's on the left and all your constants on the right. So all your constants on the right. So I'm going to add 7. And I'm going to move my x's to the other side. So I'm kind of doing it in one step here, but I moved my 7 and I moved my 2x to flip-flop their location. So what would x have to equal? Don't I get 4 x's over here? And I get positive 8 over here, so x would have to be 2. So that's a really challenging problem. You had to correctly FOIL 2 different binomials, and you had to simplify and solve for x without making a mistake. That's a really good SAT question, because they're assessing like 3 different skills with one question. All right. Let's just look at one more thing, and then it's going to be lunchtime. So the